In this video I will show you how we can convert binary numbers into decimal numbers by using a recursive call. So this is basically example. Here we want to convert this binary number 1101 into its corresponding decimal number. So we have designed a function named as bind to decimal. We will pass this binary number and this binary number will be in form of long data type, and we will pass it a decimal by reference parameter and by reference weight parameter. So this function will return the decimal number by reference, and it will also use a variable weight. So what is mean by the weight? Let us understand the weight. Here you can see that this is a binary number, and we start its weight from the right side. So the first number from right side will have a weight 0, the second number from right side will have weight 1, and so on. The third number will have weight 2. You can see that these weights are numbered from right to left. And how we find out this decimal number? We simply, what we do in order to find the decimal version of this binary number, we will simply multiply this weight like 0. In fact, we will multiply this 1 by raising 2 to the power weight. So here the first number is 1 and weight is 0. So we will multiply 1 by 2 raised to power the weight value 0 in this case. Second term is 0, and we will multiply this 0 to 2 raised to power 1 weight, the value of weight. Third number digit is 1, and we will multiply this 1 by 2 raised to power the value of weight, that is 2. Fourth digit is 1, and we will multiply this by 2 raised to power the value of weight, that is 3, and so on. And this in this way we will find the decimal value of this binary. So what is about its recursive function? When we send a number, binary number, to find its decimal number, we will initially pass decimal number equal to 0 and bit weight is equal to 0. So in this recursive call, let us see the program. In this recursive call, the first of all we have defined our base case. And how will we define our base case? We have applied a condition: binary number is greater than 0, then do this. Okay, if binary number is not greater than 0, then this function will not do anything. And the recursive function, the recursive call, that is this line, is included in this if condition. So it will call recursively itself only when this condition is true, otherwise it will not call it recursively. So this is the base case basically. And in this base case, first of all we will find the last rightmost digit from the binary number. For example, if we have number 1101 is the binary number, then will 1101 will be divided by 10, and its remainder will be get. When we divide 1101 and by 10, sorry, its remainder will be taken by 10. It will return the rightmost digit from this number, that is 1. Okay, when we divide a number by 10 and gets its remainder, then it will return the rightmost digit. Okay, so the value of bit in this case will be 1, the rightmost digit. Okay, then we are using this expression: bit, the value of bit, multiply by for the moment ignore this cast, just look at this, power of 2 raised to power weight. Okay, initially the weight was 0. So initially the weight was 0, and we have used this expression. The rightmost bit was 1, and we have taken 2 raised to power the weight value, that is 0, and we have multiplied this, and the first term we have got is 1, and the 1 will be stored in the decimal variable. Then next process is that we will simply remove the last digit from this number. Okay, how we will remove this? We will divide this binary number by 10. Now what we will get? We will get rid of last digit from here, and we will have only 3 digits in the binary number, that is 110. The rightmost digit will be removed. Okay, the binary number is now 110, and we have incremented weight value. Initially its value was 0, and we have make it 1 now, because we will move to the next digit and the weight will be incremented. Now we have called the function again. This time the binary number is 110. Decimal is, we have calculated, its value was 1, and weight value is now 1. So this function will now recursively call itself. Now the binary number is 110, decimal is 1, and weight is 0. So again, binary number is greater than 0, it will pick the last rightmost digit from the bit, and the value of bit will be 0, because you can see that the rightmost bit here is 0. So now it will multiply with the 2 raised to power the value of weight, that will be 2 raised to power 1, it is equal to, but this time the bit is 0, so 0 multiplied by whatever will be 0, and the resultant decimal will not be affected, and 1 plus 0 will be 1. Okay, and binary number, we will again remove the right digit from here, and we will then, when we will remove the rightmost digit from here, we will have 11 only. Weight value will be incremented in each iteration, in each recursive call. So this time it calls itself. The binary number will be 1, decimal will be 1, and weight will be 2. It will call itself. Then third recursive call, binary number 1, decimal is 1, and weight is 2. Now we'll again pick the rightmost bit, it will be 1, and now the value of weight is 2. So 2 raised to power 2 will be 4, so 1 multiplied by 4 will be 4, and this 4 will be added with previous value of decimal was 1 plus 1 plus 4 will be equal to 5. So decimal value will be 5, and the binary number, we will again remove the last bit from here, that now binary number will be 1, and weight value will be incremented, it will be 3 now. So again recursive call will be made. So in this sequence you can see that 11 will now become 1. Before this function call, decimal was 5 and bit weight was 3. So again we again get the last bit, that is 1, and weight value is 3. So we will multiply 1 multiplied by 2 raised to power 3. 5 plus 8 will be 13, weight will be 4, and we'll remove the last digit from the binary number, then binary number will be equal to 0. So binary number, when binary number becomes equal to 0, then this recursion will be stopped, and the resultant is that when each call will return its answer to the previously called copy, then finally we will get the answer decimal equal to 13. So this is the process of converting binary to decimal.